Hello students, this lesson is on variation functions and we are going to solve problems using direct, inverse, and joint variation. So the actual math of this lesson has to do with cross multiplying, which I know that you guys all know how to do. Remember, when you're cross multiplying, you take one diagonal, multiply 2.4 times 9, and you set it equal to the other diagonal, 2 times x. Then we can just divide to get the answer. Okay, so remember that when you're cross multiplying, we just multiply one diagonal and it equals the other diagonal. The first type of variation is direct variation. And direct variation is something that happens in the form y equals k times x, where k is not 0. We read this: y varies directly as x. Y is directly proportional to x. K in this circumstance is called the constant of variation. It's also known as the slope. So you guys already know this is a type of a linear function, okay? Think of this: y equals kx. Remember, y equals mx plus b. The main difference here is that the b value is 0. There is no b. The m is kind of like the k. That means that the graph of this is a line. The graph of all of these is a line that passes through the origin. Okay, so let's look at an example of writing this equation. Given that y varies directly as x and y equals 27 when x equals 6, write and graph a direct variation function. Well, since y varies directly as x, we have y equals kx as our initial equation. Now we can plug into that the values that they give us. They give us y to be 27 and x to be 6, so we substitute in, divide by 6 in order to solve, and we get k equals 4.5. Once you have the value of k, you're done. You can go back and write your equation, y equals 4.5x. Now let's see if we can graph that. In order to graph it, well, we know the y-intercept is going to be 0 because there's no b. That's always going to be the case with a direct variation graph. They go through 0. The slope is 4.5, so 4.5 as a fraction would be what, 9 over 2. So okay, there it is. Go up 9, rise 9, run 2, and so we would have a point right there, and so you can draw your line. You can check this by substituting the original values of x into the equation, and x and y into the equation. We get 27 equals 27. Now, when you want to find a specific value in a direct variation problem, you can just, instead of using the equation that we just did, y equals kx, you can just set up a proportion saying y1 over x1 equals y2 over x2, which ends up being a tad bit easier to do it that way. So let's look at an example doing it both ways. The cost of an item in euros varies directly as the cost of the item in dollars, and E equals 3.85 euros when D equals $5. Find D when E is 10 euros. So the first way we're going to do this is with the equation. They tell us that E varies directly as D. So that allows us to write it like this: E varies directly as D. E equals K times D. Now we can substitute the values they give us in. They give us two sets of values. The first set of values says that E is 3.85 when D is 5. So plug those in and divide. That will allow you to solve for K. Now that you have K, you can write the equation. So we're going to take K, plug K back into the original equation right here, okay, and that gives us E equals 0.77D. That's our equation. Now that we have our equation, we can plug in the second value that they give us. The second thing they ask us to do here is to find D when E is 10. So we're going to plug in 10 euros for E, and then divide to find out what D is, and we get D is 12.99. So that's the first way you can do it. The first way is to actually find that equation by solving for K. The second way we can do it is just to make a proportion. We can say that E1 over D1 equals E2 over D2. So substitute in the values that they give us, 3.85 is to 5, as 10 is to what? And now we can cross multiply. 5 times 10 here gives us 50, and then 3.85d, divide by 3.85, and we get the same answer either way. In this way, the difference is we did not find the equation. So next is joint variation. In joint variation, this is the relationship among three variables. So it's very similar to direct. Instead of just having y equals kx, we have y equals kxz. So now y, it's in the form y equals kxz. Y varies jointly as x and z. So y varies jointly as two things. The phrase y varies directly and y is directly proportional to x have the same meaning. So as long as we're using the word directly, we can say varies, we can say is proportional to, we're talking about the same thing. These words mean that we're going to be multiplying our values together. Example, the volume V of a cone varies jointly as the area of the base and the height h. And volume equals 12 pi when base equals 9 pi and height is 4. Find B when V equals 24 pi and h equals 9. So we're going to write an equation. They tell us that V, that's the volume, varies jointly as base and height. Since it varies jointly, we're going to be multiplying together. So we still have to have a k in front. V equals k times BH. Now we have to figure out what k is. So we're going to plug in the first values that they give us. They give us V is 12, B is 9, H is 4. Plug those in, and that will allow us to solve for k. When we solve this, the pi's on both sides are going to cancel. Then we have 9 times 4, 36. 12 divided by 36 reduces to 1/3. So k is 1/3. Now we can write the equation. Use the variation function. We're going to plug in 1/3 for k. So here's our equation. Our equation is volume equals 1/3 base times height, which, since we were talking about cones, you guys might remember and already know. So now we can plug in the second values that they give us. They tell us that V is 24 pi when H is 9, so go ahead and plug those in. And then that will allow us to go ahead and solve for B. Okay, and that gives us 8 pi. Great. Now, we can also, next we have inverse variation. Inverse variation is a situation in which one quantity increases as the other decreases. For example, if you want to get there faster, you want your time to decrease, then you need to drive faster, you need to have a faster speed. So if you want the time to go down, the speed must go up. That is an example of an inverse variation situation. So inverse is written in the form y equals k divided by x. So k over x is inverse, and we read this as y varies inversely as x. The graph of this has two curved branches, and it looks like this. When you're graphing these, you need to pick positive values of x to plug in to give you one of the curves, and then you have to pick negative values of x also to graph to get the other side of the curve. So when you're graphing this, make sure that you choose both positive values and negative values on your t-table to make sure you get a complete graph. Also notice that the graph is undefined at 0. There's an asymptote right here at x equals 0 that the graph will never touch. Given that y varies inversely as x and y equals 4 when x equals 5, write and graph the inverse variation function. So, first of all, they say y varies inversely as x. That lets us know when they use the word inversely that we're going to be dividing with k on top and the x on bottom, y equals k over x. Go ahead and plug in the values that they give us. They have 4 for y and 5 for x. We're going to multiply the 4 and the 5 and we get k equals 20. So now that we have k, we can write the equation, go back and plug the 20 into the original equation for k, and we have y equals 20 over x. Good, now let's graph it. Remember that when we're graphing it, we're going to make a table of values for both positive and negative x values. And then we can plot the points and connect them. Because division by 0 is undefined, the function will be undefined at 0. So here's a couple tables where I've picked some values, negative 2, 4, 6, 8 to plug in, and positive 2, 4, 6, 8 to plug into the function to see what we get. And when I graph the positive values, I get this curve, and the graphing the negative ones gives me this. Okay, great. So, when you want to find specific values of an inverse variation problem, you can also use this equation. So, just like previously with direct, we wanted to make a proportion, we can also kind of do the same thing with indirect. Only with indirect, we're going to be multiplying the two things together. y1 times x1 equals y2 times x2. So notice that when you were solving for k, you had to multiply those two things together to get k with direct. Okay, so example. The time t needed to complete a certain race varies inversely as the runner's average speed s. If a runner with an average speed of 8.82 miles per hour completes the race in 2.97 hours, what is the average speed of a runner who completes the race in 3.5 hours? Okay, so we're going to do it first by making an equation. So if we make an equation, since it says that t varies inversely with s, we're going to have t equals, okay, we're going to make an equation to find k. T equals k divided by s. So here's our setup. The time is varying. This is what it looks like for the time to vary inversely with the speed. Now we can plug in the things that they give us. They tell us that the time is 2.97 and that the speed is 8.82. Substitute in. Notice that in order to solve for k, we end up multiplying the two numbers together. Even though we started off with division, in order to solve, we have to multiply. And we get 26.19 for k. We can plug that back in and write in our equation. So here's our equation right here. And then now we can plug in the second things that they give us to answer the question. What is the average speed of a runner who completes the race in 3.5 hours? So plug 3.5 in for t and go ahead and solve for s. Notice that to solve for s here, you're going to be dividing those two numbers to solve. S is 7.28. Now, we can also do this by saying that time 1 times speed 1 equals time 2 times speed 2. So when we have inverse, we end up multiplying on one side equals multiplying on the other. So go ahead and substitute in all the values that they give us. And then we can just easily solve that, multiply these two together, and divide by 3.5 to get the answer. And either way, we get the same answer. Good. So the average speed of a runner who completes the race in 3.5 hours is approximately 7.48 miles per hour. Now, you can use algebra to rewrite variation functions in terms of k. So, notice that when we had direct variation meant y equals k times x. And when we ended up solving for k, we had to divide. So direct variation, the formula itself has multiplication. To solve for k, we end up dividing. It's a constant ratio. Compare that to inverse variation. In inverse variation, we have y equals k divided by x for our form of our equation. However, when we solve for k, we end up multiplying the two things together. We had x times y as a constant product. So direct is a constant ratio, dividing. Inverse, a constant product, multiplying. Good. Okay, let's see if we can decide whether or not these particular functions are direct or inverse. So we're looking for a pattern here. It looks like the numbers for x are increasing. We have 6.5, 13, 104, they're going up, whereas the numbers for y are decreasing, 8, 4.5. So it looks like it might be inverse. Because of that, what I'm going to try to do is multiply each of these numbers together. If it's truly inverse, they should multiply to the same thing. So get out your calculator. What is 6.5 times 8? 52. 13 times 4. Also 52. Okay, 104 times a half. Also 52. So since in each case the product is constant, we get 52 each time, that means that this is an inverse variation. For the next one, it looks like the numbers are increasing for x and increasing for y, so that makes me think it's probably going to be a direct variation, but let's divide the numbers to be sure. 30 divided by 5 is 6, 48 divided by 8 is 6, 72 divided by 12 is also 6. So, since in each case we have a constant ratio, that means it's going to be direct variation. How about this one? It looks like the numbers for x are increasing each time, and the numbers for y are also increasing. So, I'm thinking direct, but let's just check and multiply. 3 times 5 is 15. 14 times 6 is much more than 15, isn't it? That's 84. Okay, and then 21 times 8, that's even bigger, 168. So this is not following my pattern for direct variation. And if I divide the numbers, I'm not getting the same thing either. So since x times y did not give us constant, and y divided by x also is not constant, this is neither direct nor indirect variation. Okay, and lastly, let's just do one combined variation. You can have combined variation that puts both direct and inverse variations together. Quantities that vary directly appear in the numerator. Quantities that vary inversely appear in the denominator. So let's see if we can write the equation for this one. The change in temperature of an aluminum wire varies inversely with the mass and directly as the amount of heat energy E. And the only question to us here is just to write the equation. So we're going to have the temperature, the change in temperature, so that's going to be T, okay, is equal to, and now we're going to have a K. We know that the equation is always going to have a K. Inversely with the mass. Since it's inversely related to the mass, let's put the M in the denominator. Directly related to the amount of heat energy E, so put E in the numerator. And there's our equation. So that's all for today's lesson. We learned direct variation is y equals kx, and the graph is a line. We learned inverse is y equals k divided by x, and the graph is two curved branches. We have joint variation, y equals k times xz, that's where we have three variables. And we know the constant of variation is the value k. And then we had combined variation, which has both direct and indirect in it. So those are the things we learned. All right, great.